Howdy there in YouTube land. Figured I would do another shop update because I haven't done one in a while. Anyway, basically what we have here is we got a Hyphonics Elite series. It's got completely wiped out power supply. You can probably see the burnt resistors down there. Blown output transistors. You know, I honestly think these people want to run them like 16 subs at a quarter ohm load and just see how she handles before it blows up. That's my personal opinion. I've got a Panasonic TR005 that I'm going to sell on eBay because, quite frankly, I just don't have the time for this kind of stuff anymore. Yeah, it's in poor condition. It's got cracks, scratches, missing a couple knobs. The bezel up here is cracked, and of course it's missing the antennas. But aside from that, got a JL1000 here that is completely junk. Been rebuilt twice and blew it up again. You can almost see the ripple in the board. Yeah. Where there's so much current flowing through the board, it just rippled up the board. So it's totally junk. Bad caps here and here. Output transistors are completely wasted again. You know, I had to replace these two drive transformers once before because they were burned open. So yeah, I'm calling her quits on that one. This one over here is fixed. It had the classic damage, water damage syndrome. And oh yeah, here's one for the record books. You don't see this very often. Definitely for the record books. Watch this. This is an MTX 81000D. Look at that. You'll never guess what caused that. I'll show you. There's the... Yeah. Here you go. Whoops, dropped it. See that? That is actually the leftover aluminum clamps. This sucker was stuck in here like that. So, which means the amp was mounted this way, and when it caught on fire, it melted the aluminum bars. I mean, it had to get hot. It's done. And the amazing thing is, the absolute amazing thing about all of this is, it still works. Well, I had to take two of the MOSFETs from over here and move them over there because this whole side was gone. But once I did that, it worked fine. I mean, the output stage and everything's perfect. Believe it or not, those capacitors are still good, although I don't trust them. I'm going to replace them, that's for sure. I mean, I'm not going around to that because this is for a customer, and I'm not going to do a half-assed job. That's just not me. Anyway, here's an audio pipe. Mismatched transformers. This is one that I repaired before. I stole that out of a parts unit. Obviously, it didn't hold up because that side is completely blown up. This side's still good. That side's bad because that's the side that runs a transformer. I put some Kapton down there to protect the transformer from vibrating into the board, which brings to me another audio pipe over here. This is an audio pipe 1800, I believe, AP1800D. This one, the problem is pretty obvious. This side of the rail blew up, and the number one cause for these audio pipes, for one rail or the other to bust pump into that kind of condition, is right here. These wires break away from the board. That is the low voltage supply to these drivers here and here. So when that breaks loose, this happens. So we got some repairs we got to do there. Oh, and here's an American-based VFL. And yep, you guessed it, another audio pipe design. It's funny how many different amplifiers are made by the same manufacturer and same problem. So most likely one of these two windings is open. Actually no, the winding was fine. The diode was shorted. So same deal. Fun. What else? What else do I have? Oh yeah, another fine Epson, not Epson, but Edison professional product. Actually, this is a slightly better quality than I've been working on, but not by much. You notice I have the transistor pulled. That driver transistor is bad. And here's the funny thing. The driver transistor failed, but the output transistors are still good. The output transistors are still good, but the driver transistor failed. Go figure. Okay, Rockford Falls Gate. This is a R1200. I forget. I don't remember what this style this was, but same deal. Bad output transistor, which one bad driver which I replaced, and it didn't fix the issue, because come to find out that not only did it kill the driver transistor, it also killed the driver chip, which is right here. 2084, I think that is, so I have to replace that too. Which is one of the reasons why I'm doing this video, because I'm still waiting for my parts to arrive. So I'm sitting here with nothing to do, waiting for parts. Oh yeah, refrigeration guy. Bought a whole ton of these, because these are a very common problem. This is a jazz board for an Amana freezer refrigerator, and it's obvious what failed here. I cut the relay open. Come on, focus, you piece of crap. And you can probably tell, if I can get this thing to focus anytime soon. There it is. See the contact? Nice and burned. Yeah, you can see a little bit of the remains of the other contact in place. So yeah, these are all failed, and apparently it's a very common problem. One more thing. This is an Embraco variable speed compressor. I'm sure a lot of these have been replaced over the lifetime. Here's the problem with these. There's the control board. There's the MOSFET drivers. It's a VFD 3-phase brushless DC motor. There's the microcontroller. And there's the capacitors. Take a look. See how bone dry they are? And these are Matsushita, otherwise known as Panasonic. And they're a very good rated capacitor. So it's surprising that it failed, although judging by the date codes it's from 2004, and I'm sure it's had a hard life since 2004. Oh, and here's another one that failed. Look at that. Same failure, except it blew all three driver chips up, it blew all the transistors up, it blew the processor up too, so this board's junk, because the microcontroller is also short. The microcontroller voltage is right here across this capacitor, and it reads 0 ohms. Force feeding of 5 volts voltage there causes this processor to get red hot, so I know for sure it's dead. So there won't be any repair of this one. However, I think I can repair that one. Once the new caps come in, I'll throw this back in the refrigerator and get it working. Oh, in case you guys ever want to test these, obviously you need a 3-phase brushless DC motor, but this signal here is nothing more than a square wave of the given frequency. Say this one operates between 53 to 150 hertz, so all you would need is a square wave function generator, and you would plug your function generator into here using TTL 0 volt 5 volt signaling and run it at the correct frequency. So if you want to run it at 65 hertz, you would send a 65 hertz square wave into this plug. That's all it takes. That's it. You don't, nothing more, nothing less, and the compressor will run at that speed. So there's that. Oh, these are LG boards. No idea what's wrong with those. Brushless DC fan controllers. Yeah, garbage, rubbish. Let's see, this is a dryer board for a Whirlpool. These are very, very, very commonly high failure items. It's because this relay goes bad and blows a hole in the contact on the board. And I'll show you what that hole looks like when they fail. This one has a burnt resistor here. That is the evaporator fan driver. Because the evaporator fan and condenser fan are DC motors on these types of fridges. There's the evap fan and condenser fan motor controller. And actually, if you think of the 4-wire fans that are in PCs, that's exactly what they are, essentially. And that's the PWM signal to determine the speed. Anyway, see that burn mark? That's from the relay going bad and the contacts heating up, causing an excessive current draw. Burns the contact through the board. And that's the same thing that happens here. Same deal. So I just change the relays and off we go. This one's off the Sears. Bad relays. Same deal. Contacts burned. For another jazz board, I went ahead and replaced the relay in it. So everything should be good there. This is a dryer. No, washer control. Bad processor. So nothing I can do about that. It's a bad microcontroller. Let's see, what else do we have? Let me think here. Let me turn the lights on because it's dark in here. The boss is not here, so it gives me another reason to make a video because he doesn't exactly approve of videos. Not all that much. TVs galore. Some of these are broken screens. Some of them have bad panels. This one's got a bad main board, Sanyo. This one is a Panasonic Plasma. Actually, it is a TC P50X3. Bad main board, of course. So what I did was swap out the main board. I had a spare board. This is the original. Had a spare board, but the tuner, the F connector was yanked right off the tuner from who knows what. But so I just pulled the tuner off of this one and put it over there. So that fixed that unit. This one is not. This Panasonic is not so fortunate. It has the known sustained board failure. These are very, very widely known failing. Matter of fact, we purchased this one from eBay, and take a look. That's how we got it. So as soon as I unwrapped it out of the wrapping and seen that, I knew then there was trouble. So before I even bothered to hook this thing up, took a meter, measured it, they're all short. So there's no sense even messing with it. They sell a repair kit for these online, but it's useless because not only does it blow the transistors, it also blows the drivers. But I figured I could get away with just replacing the output transistors, and nope, blew them all right back up again, $75 later. So that TV is dormant, likely won't be repaired. This Samsung had a bad power supply capacitors, replaced them just to find out that it killed the main board, so that needs replaced. This Sony has got a bad panel, which is why I'll never buy a Sony, because just about all of them have bad panels. Dynex has got a bad T-Con. Let's see. This Hitachi here has got bad buffers. Let's see. Take a look at the burnt spots on the board, you see, or on the panel. See the burnt spots? Yeah, that's from the buffers going boom, which that model Hitachi is known for that. All of those Hitachis are known for the buffers exploding, which I've had some luck replacing them, but in this case, replacing the buffer ICs on the actual buffer card itself is not an option because the ICs have blown holes through the board. And I don't know where I did with those buffer boards. So I have no choice but to replace the buffers. I cannot reuse them. That one's got a broken screen. That TV there has got a broken screen, so its parts, same too, because that's a Pioneer. Those were actually decent plasmas for the day. Oh, and I got a Harley Davidson. This has a bad sound output IC. These are known for losing sound, and that's why. As you noticed, I've made marks where I tried to test it, and all the voltages are good, but there's no output. And I checked input drive signal from the DSP, and it's there. So that rules everything out but the chip. And then here's this guy here, which has a bad digital board. That's a Panasonic 3 LCD projection, and that guy uses a special plasma lamp. It doesn't use your regular old high intensity discharge lamp. It uses a plasma lamp that ignites with RF energy. Oh yeah, I'll be selling these on eBay soon. That is a 10 BP4, and that is a 16 RP4. Yeah, 16 RP4, non-aluminized. They're both good. I don't know the emissions, but they both work. They both produce a watchable, bright watchable picture. Like I said, I don't have time for that stuff anymore, so I will be selling those. Oh, that's about it. Oh, there's another Hitachi Plasma, but it's missing the brain box, so I can't use it. This one here requires a special brain to control the TV. It has no smarts in the TV whatsoever. That is just a monitor. And no, there's no power buttons or anything because they're all in the panel. Oh, and a Velodyne subwoofer. This one has bad capacitor syndrome. 33 microfarad at 35 volt. They typically go bad and cause problems. So I got some work to do there. I also have a couple of MacBooks here, and these are 2012 models, and AppleCare will not honor the warranty. Don't know why, they just won't. Probably because they're stolen or something, I don't know. 2012, shot GPU. Both of them have bad GPUs, and they're Core i7s, so it's a shame. It is what it is. I tried to reflow. It doesn't make any difference whatsoever. I just had one in here earlier that actually, if it will focus in here, this chip right here, that is a BGA backlight IC, LP 6550 or 8550 or something like that. Memory escapes me, but you can tell this one had similar issues. Look here. Contacts are burned. That motherboard's dead, and these logic boards are about anywhere between $400 to $800, so I will not be purchasing one. They are way too expensive. It's a shame, but these things are garbage. Whatever. Oh, as I was saying, that backlight IC, I had to replace one of those on an A1276 model from it was a 2010 model. That IC was actually blown, and I was able to replace that, and it was a pain in the ass, but I was able to do it and got the machine working again. But those two were junk. Thank you for watching, and until next time.